what we're going to take a look at here is graphing linear inequalities. When we first start, we have to think about, one, what kind of line we're looking at, whether that be dotted or solid, and then we have to figure out where in relation to that line are we going to shade, on below it, above it, to the right, to the left, and that's what we're going to take a look at. The first step is to identify what kind of line we're going to have. Here we would have a solid line because we have a greater than or equal to sign. From there, we're going to graph the boundary line, which here would be negative 2x plus 3. So just like we've been doing, we're going to graph that. We know the y-intercept here is 3 because of this. This is in slope-intercept form, and our slope is negative 2. We would go down 2 to the right 1, down 2, right 1, down 2, right 1. And we know we're going to have a solid line through here. Now, to figure out what side we're going to shade, we're going to test the point 0, 0, because that is not on this line. If it were on the line, we have to pick a point that is off of the line. So we take 0, 0 and we plug it into the inequality and see if we get a true statement. So if we plug in 0, 0, we would have 0 is greater than or equal to 2 times 0 plus 3. We go through, we reduce this. Negative 2 times 0 is 0. And we get this statement. 0 is greater than or equal to 3. That statement is not true. 0 is not greater than or equal to 3. So what that means is 0, 0 is not a solution. So this side, all of the rest of these points then are not going to be solutions to this inequality either. What will be is everything on the opposite side. So we would shade everything across from 0, 0. And we would do the same thing down here. We have the line 2x plus 3y is less than or equal to 9. First, we want to identify what kind of line we're going to have. Again, it would be solid because this is less than or equal to. We could say that is going to be solid. And now our boundary line would be 2x plus 3y equals 9. You could graph this straight from standard form, or we could graph it in slope-intercept form. If we were to graph it standard form, we want to find the x-intercept and the y-intercept. Again, to find the x-intercept, we plug in y equals 0. You would say 2x plus 3 times 0 equals 9. And we go through and we solve for x. 2x equals 9. X would equal 9 over 2, which is 4.5. So what that means is we would have the point 4.5, comma 0. We'll go ahead, 1, 2, 3, 4. Right around there, plot that point. Our y-intercept, we would go through and do the same thing. It's just now we're going to plug in x equals 0. We would say, I know I'm kind of running out of space over here, 2 times 0 plus 3y equals 9. Sorry, not a lot of space. Time to start working down here. 2 times 0 is 0 plus 3y equals 9. We would have 3y equals 9. In the end, you get y equals 3. So we would plot that point, 0, comma 3. 1, 2, 3, right here. And again, just like before, we would go through, draw this line as such. Okay, now again, 0, 0 is not a solution to this, or I'm sorry, is not a point on this boundary line, so we could use that as our testing point. We'll go up here, we'll say 2, 0 plus 3 times 0 is less than or equal to 9, and we check to see if that's true. 2 times 0 is 0, 3 times 0 is 0, and we check to see, is that less than or equal to 9? 0 is less than or equal to 9, so 0, 0 is a solution, and so will everything on this side. I'm having a little trouble here. Okay, everything on this side would be a solution to that equation. I'm sorry, that inequality then as well.